Okay, this is screencast number 2 for topographic map worksheet help, and I'm looking at topographic map worksheet number 3. And on the back or on another piece of paper, I don't remember how I copied it, whether it was front to back or on a different sheet of paper. But anyway, you have some questions that go along with this map that we're looking at. And I want to jump to question 53. Question 53 says, describe the evidence shown on the map that indicates the southern side of Holland Hill has the steepest slope. Well, let's go to the map. And we see that this is Holland Hill. Remember, you've got a compass direction down here. So we know that north, south, east, and west. Okay? The south side of Holland Hill is the steepest. How do I know it's the steepest? Because the contour lines are closest together on the south side of the hill. And that's all I really need to write. I know that the south side of Holland Hill is steepest because the contour lines are closest together on the south side. Okay? So you can just write that in for question number 53. Then we're going to work on question 54, construct a topographic profile from point A to point B by following the directions below. Well, you don't get the directions, but I'm going to walk you through how to do this. You're probably going to need an index card because you're going to lay your index card along the hiking path, that's this dashed line, from A to B. Okay, and we're going to use that index card to help us construct a vertical profile. All right, I've sort of done the quick version. I've already marked all of the places that I need to mark. I need to mark a little hash mark for where A is, and I'm going to make a little hash mark for each line. Each time I cross a contour line, I'm going to make a little hash mark. And then I also make sure that I mark where I cross the river, because this dark line, that's not a contour line, that's the river. And I'm also going to mark this high point because I crossed the high point, okay, and I mark that at 533 feet, okay? And I'm going to go back and put the elevation that goes along with each contour line, okay? So if I look at the map, I can figure out that A is at an elevation of 520. Okay, this one's 530. It's the same as this one. That one's also 530. This one's 520. 510. And then I've got a line marking the river. 510, 520, 530, 540. And B is at 550 on that index contour line. So I mark all of that. And then I'm going to take those markings and I'm going to transfer them to my graph. All right, notice I have my index card handy, and the graph is made so that the sides of the graph line up with the beginning and the end of my hike, A and B, okay? And all I have to do is I have to take my index card and slide it up or down to the right elevation to make my marks. So here we go. A is at 520, so I'm going to slide up to line A, or to the 520 line, and mark A. Well, A happens to be already marked with an X, okay? My next marking that I need to make is at 530, so I'm going to slide up and mark at 530. 533, I'm not going to move my index card. I know that 533 is going to be somewhere right about here. And then I've got a mark to make at 530 again. All right, my next one's at 520. So I need to slide back down to the 520 line and make a mark there. Slide down to the 510 mark and make a dot there. Another 510 dot. And I'm going to move this down just a little bit to mark my river. I know my river is a little bit below 510, okay? All right, continuing on, I need to go back up to 520. I need to go back to 530, go up to 540, and then notice B is supposed to be at 550, and B is already marked. So that's what I get. And then I'm going to connect these with a smooth line. Okay. And this is what we call a vertical profile. It gives you an idea of what you're going to be doing if you hiked from A to B. So for instance, here you're going to be going uphill and then downhill, cross the river, and then you're going to be going uphill again. Okay? Sometimes these are called topographic profiles. You might hear me call it a topographic profile or a vertical profile, either one. They're both correct. Okay? But one more time, all you have to do is when you decide that you're going to hike from A to B, mark all your contour lines and then put it on the graph. Okay? All right, I want to cover one more thing with you, and that is number 52. 52 asks you to calculate the gradient between points Y and Z on the map. When we do gradient, first thing you need to realize is that gradient is basically another way for me to say slope. So gradient and slope are the same thing. And if you know from math class, slope is rise over run, okay? How much your up and down value is changing versus how much your horizontal value is changing. So I also put it just in symbols, that slope is the up and down divided by the side to side. Okay, gradient's the same thing. It's just it looks a little bit different because we're saying elevation and distance, but it's basically how much is your up and down changing versus how much is your side to side changing. Okay, the formula for gradient is change in elevation divided by change in distance, and that's horizontal distance, by the way. Okay, so number 52 asks you to calculate the gradient between points Y and Z and label the answer with the correct units. Okay, well, first of all, let's take a look at Y and Z. I actually already know their elevations because we did that a little bit ago. Y is at 490 feet, and Z is at 520 feet. So if I went from Y to Z or from Z to Y, my change in elevation would be 30 feet because 520 minus 490 is 30. And then what do I do about the horizontal distance? Well, the horizontal distance, I'm going to use my distance scale down here. And probably the easiest thing for you to do is just to redraw the distance scale, maybe on a Post-it note or something, and pick it up and move it and measure your distance with that. Okay, so to find horizontal distance, I am going to retrace my distance scale from the bottom of the map, and I am going to lay it over here, okay, next to my 2 points, and you'll see that going from Y to Z is a distance of 5 miles, okay. So I'm going to come down here and put 5 miles. 30 feet divided by 5 miles is 6 feet per mile, and that's my gradient, meaning that I am going to change my elevation by about 6 feet for each mile I walk. So this is a relatively flat gradient. Okay, for something that is pretty steep, then the gradient's going to be a lot larger, maybe 200 feet per mile or 1,000 feet per mile or what have you, okay? Just tells you an idea of the slope, and slope is, you know, how steep a hill is, okay?